Hello and welcome. This is ChronoPlatformer Game Dev Stream number 27. We're going to go ahead and get started tonight. I'm going to take a look at what I've got on Jira, but I think I'm going to focus on something else. Not something else necessarily, but I'm going to take a sort of tangent. Last time we were looking at the ramp platform and having some sort of issues with the ramp platform because I want to have the character slide if it's too steep. Hi, I'm W2 Melvin's dad. Thanks for joining. And there were some issues with the ramp platform, or there's some issues with the character controller and trying to get it to be, the too steep stuff. So anyways, I was watching this video earlier today about a concept in Unity called Scriptable Objects. So I'm gonna look at doing the Scriptable Objects here. Basically, the premise is that we can use Scriptable Objects as a way to set up data more easily in the editor. It gets into it right about here.
We use has a much more generic version, so the code's fancier, not really good for demoing. So here I'm going to be defining a scriptable object, create asset menu. That's something that's important to make sure you can create an object from the right-click context. Public class float variable that is a scriptable object. Curly braces on the next line because we're not monsters. .NET has standards. Thank you, yes. We're going to define a value. We're not naming this value. We're not naming it HP. We're not naming it range that we attack from. What the variable gets named in the project view as the file on disk, that's what's going to hold the name. That's what's going to hold the meaning. And this is something that a designer can do. They can make these at will and drag and drop those references places. And here's where the class actually gets really interesting. This is where it gets fun. So that's it. If there's anybody here that can't understand or complete this coding task, I'm sorry, the rest of it's not going to get any easier. So in this case, we can do hit points, damage amounts, timing data, all these things for enemies, and we can have those different components reference these variables. And we'd have some stupid enemy, of course, be on the next line because we're not monsters. And variable max HP is a float variable that this references. Same with move speed. There's something that can be really annoying with this workflow, though, and that's that this can get very cumbersome. We want every bit of data to be able to be grouped like this, but it's kind of annoying. Like maybe this one we just want to type in the float value. So we just made this layer on top of it we call the float reference, which is a serializable class. That we have this option of saying, do we want to use a constant or do we want to use a variable? And we just can go through that, and this way, designers can say, just use this data instead, or actually I want to use this shared data. With this pattern, once we actually look up the value, it's going to return the one that we would expect. But now, Now we can go in and almost any float that's exposed in the inspector in our game, we now make a float reference, and it's made it exceptionally more powerful for our design team to use that to configure stuff and make sure that values are in sync across each other.
So I was watching this video, and I think this is a really cool idea. He talks about how it gets used a bit later, and I think it's worth me spending some time to do this now for some of the values I have in various scripts. So I'm gonna work on making the infrastructure for this first. Okay. So this is going to go inside of system and then scripts, and then I don't know, I think this is broad enough to leave it out of one of these folders. So I'm going to create a new C# script. And this is going to be called so he calls it a float reference, and the float reference allows you to have it conditionally be tied to a scriptable object or to have it be hard-coded. I don't really like the name float reference. I kind of want to come up with a better name than just that. So I guess the first thing is that we have to get the underlying class in place. So he does it's called a float variable. And it's not a mono behavior. It's a scriptable object. And actually we can make a couple of these. I'm gonna have to rename the file, but we can have a couple different things in here. So we can do a float variable. We can do a bool variable, an int variable, maybe a string variable. And then the other thing he has is create asset menu on all of these guys. So if we do that, then it'll show up somewhere else. But there's some syntax for this we want to make sure we're using. So let's go to the internet. Unity create asset menu. So I want to have the path like this. I want it to be so let's do that. We'll give it file name equals new float. This is just a placeholder name. It gets changed. Do menu name equals scriptable variables slash float variable. Lastly, the order, set this to 1. So now, if we ever want to make one, what we do is we right-click and then hover over Create, and at the top we have Scriptable Variables, Float Variable, String Variable, Bool Variable, Int Variable, and it will just make one of those. So that's how that works. It's going to be pretty handy. Now, I'm going to create another script that's going to be the overlay on top of this that's going to allow us to go between a constant value and the scriptable object. So this will be, I'm going to call these dynamic variable or dynamic reference variables. And I kind of want to open up the other one here, and I'm going to sort of copy these over. It's because they're going to be really similar. That's what it's called, serializable. Okay, that works. Oh, maybe not. Oh, it's because I didn't finish. So public bool is constant. Public float constant value. Public float variable. So I think I want to do that. So I keep them private, but when I do the serialized field, it lets you still access them from the Unity editor. Oh, one other thing is that this is constant, needs to be set to true, or it needs to be set to one of them by default. Cool. Now we should be able to do the same thing. Here, go create. No, that doesn't show up. So he doesn't have it as a serializable object, but or a scriptable object, but he gets it to show up in the editor later.
To use that to configure stuff and make sure that values are in sync across each other. So now our dumb enemy doesn't take a float variable, it takes a float reference. Simple enough. On top of that, I love doing over-the-top inspector work. We can make an inspector that makes this kind of fit into one line and be a lot more elegant to work with. And this seems like it could be a trivial addition to this, but it's my belief very strongly that making inspector, this was actually a property drawer. Making property drawers to solve these problems that make it look like it's a part of the Unity editor is actually a huge benefit for your design team, because there's patterns that they're used to already. And my goal has been to convince everybody on the team that this is actually a feature of Unity. And that's happened a few times where a designer on the team that I'm working on now, we're on an older version of Unity, he said, I don't think I like Unity 2017. They removed float variables. So I'm very proud of that. So here we can, this is, going back to the float variable now. So now we know how to reference it. There's actually some functionality that is hidden in here that we might not have picked up on before. So we talked about having a designer specify this is max HP. These are all these other things like move speed. But we can do some other really cool stuff with this. That value, that float value, can change when the game is running. And anything else that's referencing that value will get an update. So if we think about the way Unity's animator works, it exposes.
So he's got a GitHub here, and I'm curious to see if he has the float reference or the editor script he uses. Here's a string variable. it does. Cool. Custom property drawer type of float reference. Public class for float reference drawer. Property drawer. Oh, I was muted there for a minute, but yeah, I'm basically just saying I want to get this sort of drawer thing he has, because that seems really handy, and yeah. Well, let's just see how it would look without it. So, so let's go to characters and then prefabs. And then we have our character here. Gotta have that over there, I think. So I think I need to have a new folder in here that I'm going to call Scriptable data. And then I'm going to go open my horizontal movement. I'm going to try to replace one of these. So we have this one here called max speed. I'm going to try to replace it. So we're going to make this public, and we're going to do float dynamic reference. And now let's go inspect our character. Ooh, that's an interesting error. Oh, the issue is just everywhere else that the max speed is being used in this script. I have to fix that first. Yeah. Yeah, I did tilt some of the blocks. So it's not showing up like I thought it would because this is not a mono behavior, so it won't show the scripts in the editor or the variables in the editor. How do we get around that? Well, okay, just to get this to show up the way I want it to, I'm gonna move this, I'm gonna copy this into here. And then I'm gonna make it a parameter to the into the thing. I think I'm gonna rewrite all this stuff, but I want to see what this looks like in the inspector for now. Okay. Okay, this is good enough. So if this is checked, it uses the constant value. If not, it uses the other variable value. And so we can do this now in the project. Click on characters. Click on characters, and then I mean, really, I don't even want this one off to the left. I don't know if there's a way to get rid of that. Okay, characters, and then scriptable data, and then we're going to right click and we're going to go create scriptable variables, float variable. I'm gonna call this player max speed. Okay, and we can go set the value. I think we had it at 5. Okay, now on the character, we can drag this player max speed into here. Oh, that's annoying. So we can't put that all into one file after all. System scripts. Scriptable variables. Okay, I'll create a new one. Call C# script. We'll call this float variable. Create C# script. Bool variable. Int variable. That's the string variable. Get all those open. Int float bool string. Okay, now I'll cut the float out of this one. And put it there. We'll cut the bool out of here. And we'll put it there. Let's do the same thing for all of the dynamic references I came up with before. So we'll do float dynamic reference bool dynamic reference int dynamic reference, and lastly string dynamic reference. And now I'll do the same bit of work here. Now back to the prefab for the character. We'll open them up and we'll go back to scriptable data, and we'll make sure to drag this. Got this max player speed here. Gonna drag that into the character. Let me delete this one and start over since create scriptable variables float player max speed. Okay. So now if we go to play, this should work, and our value is stored in this thing. The value isn't really obvious. The reason for doing this isn't very obvious here, but he had an example in the video, which I won't play through, where he has a scriptable object that is referring to the max health of the player, and that was super useful because then that reference could be easily added to both a health UI user interface component and the movement component, or the health component, whatever. Okay, so I'm not super happy with the current state of the player controller. And so I was also reading a bit on some on like how to make one. I found one, 2D character controller Unity. I found one that Brackey's had on GitHub that was free. I'm not just gonna take this and use it because, well, there are some things I wasn't super fond about it, but I do want to throw it in to my game and see how I feel about it. See about how it plays and stuff. So he talks here about what abilities it has. It has smooth movement, jumping, crouching, event delegates for setting up animation, and then 2D physics. And then he's got a video explaining it on his channel, which I'm not going to watch. So he's got the way that he does it is, rather than having like a specific collider for the ground, he's actually got a position or a transform like at the bottom of the character, and that is the ground of the character. And then if you're within a certain distance of that, then you're considered grounded. And so that solves the problem of having, you know, one large collider. And then they've got a ceiling position as well for checking if you can be crouched underneath of something or not. And then this is all controlled by input here, which tells you if you're like moving and crouching and jumping or not. So I do want to take this and use it for a bit. So I'm going to make a new, I'm going to get rid of the character here. I'm going to make a new, oh, that's a lie. I'm going to start with the character. I'm going to delete some other stuff off of it. Alright, just kidding. I guess I can't delete children of a prefab. I guess I'll just start with a new object then. This will be called Brackey's character. I'm going to give it a sprite renderer. And then in the scripts folder, I'm going to make a new script. Call this Brackey's movement. So his is looks pretty complicated here. The functions are not that big, which is nice. And it's a mono behavior, but he's got a lot of variables. So he's got a jump force because he uses dynamic rigid body, and he's applying forces to it. He's got a crouch speed, which says he's going slower when he's crouched. He's got movement smoothing, which I don't fully understand because I don't know how this smooth damp function works. Just don't even know what that is. I'm guessing it moves the rigid body's velocity towards the target velocity, but like not too quickly. I don't know. See, I also don't know why he's just got this 10F here. I guess that's his like side-to-side move speed. You think that should be a variable? Because this move value is expected to be between 0 and 1. He's got this air control, which lets you determine whether you can move while you're in the air or not. He's got a layer mask, which is a good idea. That tells you what is the ground. The transforms for the ground and ceiling check, which I mentioned earlier. A collider that will be disabled when crouching. Okay. And then he's got this grounded radius. It's like determine if you're grounded or not. Bool to say if you're grounded or not. Ceiling radius. Rigid body of the player. Whether or not you're, which direction you're facing. And then your velocity. And then he's got an on land event and an on crouch event, which other things can listen to. He's got this was crouching variable. On awake, it gets the rigid body from the character. So we're going to need one of those. And then it creates the new Unity event delegates. On every fixed physics update, it says was grounded is its current grounded state, says it's not grounded. And then it does some ray casting here. It does a circle cast. And then gets all the things it collides with, and if any of them are ground, that's the layer mask. So if any of them are ground, it adds them to here. Checks that they are not the game object itself, which is kind of weird. And if they're not, then we're grounded. And if yeah. But this seems weird because then on land event could be called more than once. I feel like there should be a break after this. or a return or something. Like, once we've determined we've collided with one thing, it should probably stop. Because otherwise we'll get an on-land event twice. And then we have to have some other thing that gets input and calls this. And this is called every update call. Comments here are pretty good. Get the target velocity, you set the velocity of the rigid body, potentially flip the character, and then the flip basically just changes the scale from -1 to 1 and back. And if we're grounded and we jump, then we apply a force to the character, and it gives a jump force here. And I don't particularly like doing jump force because it gives you a force does not give you very much control over your jump. And also he has no system here for a double jump. But I think there's a number of things to learn from this and to kind of cannibalize. Like I like the simplism of the ceiling and ground check, or at least the ground check in particular. Like I said, I don't have a plan to let the player crouch beyond just like part of the jump animation. But let's see if we can hook this up and get it working on a character. So Brackey's character needs a 2D rigid body. And it is dynamic. And then we'll add a Brackey's movement to here. We'll give it air control. And then we'll select ground as what is ground. Brackey's character needs to child object. This would be a ground check. And then we have a ceiling check. That's going to be his head. So the ground check goes into that one, the ceiling check goes into that one. And then we're going to have a collider 2D on here as well. This will use a capsule collider, I suppose. These little green squares are so hard to click. Okay, that looks good. Okay, then we need to take this capsule thing and put it into here. and now I need to call the move function by some means. So there's going to be a new script for this. Scripts gameplay. Call this script brackeys input. And the brackeys input is public brackeys movement. And then on update, we need to do input dot movement dot move. It takes in these things. And I'll say input mapping dot get instance dot is dot get movement direction. Maybe the rigid body does have to be kinematic. I didn't think that you could apply a force to a kinematic. But suppose the script is applying the force to the rigid body. Yeah, no, that's what yeah, no, I still mean what I meant. So it is dynamic. He just froze the rotation. And I just don't I don't quite understand why this dies so hard when it hits this. Collision detection mode. That one's interesting. What's that all about? The only way I could see with this that this could actually work is if you did a capsule collider like half the height and then a box collider up here. Like that, and then the box collider was what got disabled on crouch. This almost has to be the way it is. I don't know if there even is such a thing. Now you see I do collide into this wall. But when I hold down S, I do not, because I'm crouched. I also move slower. I bet that's what he's going to end up saying in the video. I'm too curious now. Dang it, he got me.
Essential parts of creating a 2D game is of course player movement. And even though it's one of those basic mechanics that we often take for granted, creating a really good player controller can actually be quite challenging. In fact, it's something that even experienced programmers can spend weeks or even months of development time getting to feel just right. Of course, everything depends on what you want your character to do. Can he jump? Can he be controlled in air? Can he crouch? Can he wall run? Does he slide down ledges? What about animation? And so on. Now that might sound a bit overwhelming, but as always with game development, there are ways that we can choose physics material. To do that, we'll go to our project and hit create, and we'll then select physics material 2D. And we want to create a really slippery material so that we will simply slide off. So let's just call it slippery. And in here we can adjust two settings, the friction and the bounciness. We want the bounciness to remain at 0, and we'll also set the friction to 0 as well. Then if we select our player, we can take this slippery physics material and drag it into the material on our box collider.
Ha, I was right. He does. He has a circle collider, which is down at the feet, and then he has a box collider that goes up to the guy's head. And then he uses the box collider to disables that one on the crouch.
And now when we play the game, we can see that we slide right off platforms. We can still get stuck on the very corner of the circle. If this happens or not is going to depend on the way you've set up your colliders. In our case, we can simply go ahead and add the slippery material to there as well. And you can now see that we fall right off of platforms. And at this point, some of you might be wondering, well, we just wrote jump. Why does this jump variable correlate?
Okay, I don't need to know that. Alright, I'm gonna save that Brackey's character just because that's like, it's kind of nice. And yeah, so a couple benefits of using a dynamic rigid body is that you get to use the physics 2D stuff like he was talking about. So he's allowing the colliders to act sort of normally, and then because he applied this slippery physics material to those colliders, you don't stick against the wall when you're moving like I was doing. So I think I would like to rewrite my scripts that I have. I've got the horizontal movement in the jump processor, but I've also got other stuff in here that I don't think belongs. So like most of the horizontal movement is stuff about collision, and I don't know if I want the collision to be in there. And most of this, like about half of the stuff in the jump processor is this jump state machine, and then the rest of it has to do with collision. So I think that collision stuff could be combined into one, and then the other things be split out. And then using these new scriptable objects we can share things like the jump state. And that would be really handy, because then the animator can key off of the jump state. But the animator doesn't have to know the jump processor exists, and the jump processor doesn't have to know that the other exists. They do each have to know that the jump state scriptable object exists, but that's a different story. The problem is that the jump state is an enum, and it's not a float or an int or a bool or a string like we have set up these scriptable objects for. Luckily, this guy's video here does have a section where he talks about enums. He says no more enums, but unfortunately he kind of speeds through it, and I don't think I fully understand what he's getting at. So I'm going to pick up where I've not yet seen, which is starting here.
Very useful for something like player HP. But there's a lot of cases where we don't actually care about the data that we're passing. We just want to say something has happened and I would like you to respond now. So now we're going to talk about event architectures, also surprisingly scriptable objects. An event architecture helps modularize systems, much like these float variables do. And it lets you reuse them in other projects. At our studio, we have a lot of projects running at a time, and we have our own Unity framework. So something that we can do to connect these framework modules to our project is always something that we need to come up with when we start a new project. And using an event architecture allows you to just drag and drop something in, and okay, the bindings between this and the systems in our game, we'll make those be events. It helps isolate prefabs, much like those variables. And a prefab can say, I respond to an event, and I don't care where it comes from. So if you raise it, I'll do whatever my prefab tells me to do. And it's a little bit of an optimization over the model of the variables. So an HP meter, you might want to have that watching closely if your HP is a wide range. But in a lot of cases, you don't want to be busy checking, what do you now, what do you now, what do you now, what do you now? And instead, just have a one-off event. It's also highly debuggable. If you can invoke these events through the editor or through other systems or through a UI, it's easy to identify if the event's raised, is the behavior correct? Yes. Well, is the event being raised? Yes. And if you go down that search flow, you can kind of do a binary search to hunt down where your bug's coming from, on the raise side or on the response side. Unity has this thing called Unity event. That seems like the first place I should look if I want an event in Unity. This was introduced, I think, in 4.6 with the UI system. So its primary focus was what happens when you click a button. So it looks like this in the inspector. You can pick an object, and once you select an object, you get a drop-down of all the functions that you can call on that object. So here you can call other thing.setActive to true. This is in my mind, not really an event. It's a very useful tool, but this is actually more of a serialized function call because you're saving out ahead of time exactly what you're going to do. There's some advantages to this. This is still a very useful pattern. We use it everywhere. You can hook things up in the editor, so this allows for things to be modular, and you don't have to have code, that sort of last meter that connects one system to another. You can just do that using these Unity events. So your code doesn't need to assume it's bound to a button or it's bound to a collision. It allows you to pass arguments. I'm not going to get into...
I don't think that you can save this, though. Right? Like if you save a prefab that has a Unity event, I think that information disappears, which you might talk about.
Depth on that too much, but it's one of the things that people don't always use with them. You can extend Unity event with whatever type of the argument you want to pass. So Unity event bool, and if you declare that as serializable, you can use that new class as something that you can pass data with. When you do that, the arguments are either static or they are dynamic. So let's take a look at on example needed with a Boolean. So other thing, .setActive, if you click, you get this new section up top that is dynamic arguments. So at the bottom, you have arguments that you can just specify in the inspector. And if you select one of these, this means that it's going to wait for the event to be raised in code with an argument, and it'll forward that along. There's still some problems with this. As I mentioned, it isn't really an event system because it relies on rigid bindings. So if you use an event for a button response, that means a Unity event for a button response, that means that that button needs to know exactly what object responds to it. So if you want to keep your UI in its own prefab, which I would recommend, and have some system that's not in that prefab respond, you have a challenging system now. Now you need to make an awkward class at the top of your prefab that responds to every single button click. And when you make a new button, you have to go in and make a new response. So this becomes a little bit of a problem when we're trying to modularize and extend things. Yes, the hard references in the button are the problem. And there's some limited serialization with Unity events. The capability of a Unity event far surpasses the serialization model that they use for the Unity event. What I mean by that is with the Unity event, you can define something that takes up to 4 arguments, and those arguments can be just about anything. But the only ones that you can actually edit in the inspector are if it takes 1 argument, and the argument is an int, bool, string, one of the first-class primitives that Unity treats, or Unity engine.object. So you do run into some issues when you're trying to serialize out different Unity event responses. And also, there's a garbage allocation. Since it's a serialized function call, it's using the string to resolve what message gets the response. So every time you call that, you're going to see a little bit of garbage. This doesn't make them useless. It just means you don't want to call it every frame. If something happens every frame, it's not really an event anymore. So how do we extend this? We're going to try just making our own events. So we want to make them data-driven, obviously. Make sure that they can be designer authourable. So again, probably going to be a scriptable object, spoiler. And make sure that they're debuggable. It's going to look a little bit like this. Create asset menu, because it's a scriptable object. We'll call it game event. Curly braces, the next line, we're not monsters. We'll have a list of game event listeners. And all this really is a class that I'll get into real quick. What happens when we call raise on this game event? It's going to loop through all of the listeners and call on event raised. An interesting thing about this loop is we're looping through this listener list backwards. And the reason why that's a useful pattern to use is in case an event's response or a listener's response includes removing it from the list. That way you're removing items behind you instead of removing items in front of you. So you can iterate through the list without an out of range exception. And then 2 functions that are not super important to really define, register and unregister, just add and remove it from that list. There's a lot of optimizations based on the number of listeners you would have in this thing. You could change to different data structures, but kind of as an abstraction on the system, the list is a good starting point. You can always end your classes. So the game event listener, this is the other half of that. This is a mono behavior. So the game event is a scriptable object. Game event listener is a mono behavior. Oh yeah, next line, not monsters, whatever. The game event is something that's referenced. So this is in the inspector. You can drag and drop the reference to the game event you want to respond to. And then use a Unity event to serialize the function call as the response. So now if you have a prefab and you have an event listener at the top of your prefab, you can decide what message do I listen for that's going to come from outside of my prefab, and then what response do I have inside my prefab. So now it's much more reliable. Your Unity event knows exactly what, or the objects that's responding to this event knows what the context of this prefab is. So it can have that Unity event response and not need to rely on external prefab data. And in this case, we'll say when the object's enabled, it registers itself as a listener, and when it's disabled, it unregisters itself. And this shouldn't be a surprise. When the event is raised, it's going to call response.invoke. I'm going to show a demo. I'm going to jump into the same cube exciting game here. This is kind of the where we left it off before, but we're going to add a damage effect. So we wouldn't want something constantly checking the HP saying, did I get damaged? Did I get damaged? Did I get damaged? So we'll make this work like an event. Here I made an addition to this unit health class. No, spinny bar. When there's a collision that happens on this player object, it's going to invoke this damage event, which is just, here it is in our scene. We can create it by saying create, blah, blah. It's in here, I swear, game event, just like that. So player says game event dot raise. That's what this Unity event's going to trigger. Then somewhere else in the scene, or maybe it doesn't even have to have a presence in the scene, we'll have something respond to that. So here we have game event listener. So this is just a component that all it does is what we talked about. It listens for an event and calls a response that is a Unity event. So it listens for on player damaged, and the response is emit 40 particles and play a sound. So you'll love my programmer particles. But as this happens, it just gets that event. As far as debuggability is concerned, if you just write a simple inspector, you can come in here and click on player damaged and raise that event as much as you want without actually having to recreate whatever setup gets you to that place in your game. Player damage is simple to recreate, but a lot of events are much more complex in our games. We can keep adding to this, and let's say when the player dies, there's now 2 new prefabs, death sound and death screen. Programmers don't even know that this stuff's happening because an artist can just make this thing that responds to an event and turns on. So here, when the player dies, we're going to raise this on player killed, and it's going to turn off the player object. So let's make that happen. So there we go. I forgot to not have a broken bug. Sorry. There's supposed to be a bug right here so I can fix it in front of you. I guess it's a bug that there's no bug. So here, I'll reintroduce the bug. So now the player's dead, and the heartbeat's still going, which is very annoying, and very clearly you're going to get somebody reporting that to you in QA as a bug. When you're in late stages of QA and you can fix something in your game without having to write any code, it's so much less stressful. You don't have to retest all of the systems, just that one thing. So here's how we would fix that. We have this warning sound. All we need to do is add a game event listener to that. That's going to listen for player killed, and the response will be to turn itself off. That's it. So now when I play, which you've all seen this before because it wasn't not broken. It turns off the sound. You can see that this game object has been actually turned off. So now we've fixed the bug by just adding one single component that affects only that object. So scriptable objects are
Unit health script.
when great for this modularization of data, making things into smaller pieces and smaller messages, but there's still some things about like the singleton pattern that we haven't solved yet. So one of the big things that a singleton still wants to do is they want to have, in the case of an enemy manager, you want to track all the enemies in a scene. So every time an enemy gets placed in the scene, it's going to, on enable, say, hey, I'm here. And that way the manager has this high-level view of everything in the scene. This still can create race conditions. Similarly, an enemy manager would want to understand where the player is, and it would want to take that list of enemies that it has and say, hey, do this thing to this player. So there's more than just a collection of data there. There's actual functionality that's implied. And we can take a look at this and see what some of the problems are. As I mentioned, there's race conditions. I'm sure many of you have been in a world where you put an object in a scene and player or enemy manager.instance is called and it hasn't been created yet, so you get a null reference. Or it's checking if it's been created, and if it hasn't, it doesn't respond, which means that enemy doesn't get added to the list. Also, we're dealing with the same rigid singleton problems where if we have an enemy manager that does this stuff, we can't do that test scene that I talked about where we placed a bunch of enemies and we needed to bring in every other system because of its rigidity. And still, there's only one. So we can address these with this feature I call Runtime Sets. These are going to be almost exactly like the float variables, except instead of a float, we're going to be dealing with a list. So we can keep track of a list of all the objects in the scene. That's one of the goals with this. It'll avoid race conditions, because if you're referencing a scriptable object, its in-memory copy is available when you reference it. There is no, you don't have to manually initialize this. It's just there. And it's going to be more flexible than using Unity tags or a singleton, and more performant than calling find object of type. So Unity tags will let you say, yes, I'm an enemy object, and there's a special list maintained of all of your special tagged objects. That's also using strings, so it's very likely to be error prone. And you can only have one tag on an object, which to me just, that's not really what a tag is. That's more of a label. So we'll take a look at how we build these, also very simple. Here I'll just do it as an abstraction because it is a little bit fancier. So we'll have a scriptable object that has a list of items. In this case, they could be enemies, or in my example, they will be cubes, because that's very exciting. Like an add that will add it to the list, much room for optimization on the lists here, I'm sure, and a remove that will remove it from the list. Also, all very simple. And this is all stored on a scriptable object, so you can have something in your scene reference that object. And we've used this type of pattern before when you have an RTS game. When you place a building in an RTS or build a unit, you want something that has an RTS object. Simple. And this is also for all of the buildings. Unit, you want something that has an understanding of what are all of the units, what are all of the buildings. It's also very common that when your game is fully in production, you'll have maybe a designer says, oh, but I also want to maintain a list of the flying enemies. And we don't necessarily have coding resources available at the time to code in a new list of flying enemies and the rules for looking that up. So we could very easily just say, this enemy, or here's a new component that says add it to enemies list. Also add it to flying enemies list. And then we can maintain these lists kind of just based on whatever components we add. We also use this, and actually this was the first time that we started it, was for special effects. So we had a custom renderer that our graphics engineer, Joe, wrote. And here we needed to reference some renderers and do some dirty stuff to them to get some really cheap and nice blur and glow on them. So our rendering script needed to know about every individual renderer. And since our graphics engineer isn't a full-time member of the project, he shifts around and solves really hard problems for all the projects. There wasn't a lot of time to understand how the game's all put together. So instead of actually having this integrate with some big part of the system, it just put that into the in-memory copy of the scriptable object, and then we were able to, on start, we would have all of these special renderers write themselves to that list, and whenever the camera went to render, it would just go through the list and say, hey, here's a new renderer. And it didn't care where that data came from. Similarly, you could do this with items on a mini-map, so anything that wants to display on your mini-map can add itself to a list, and your UI component can inspect that list and say, for each item in here, we're just going to draw whatever icon we associate with it. And I have a demo that is less exciting than any of those, but it demonstrates this with cubes. Cubes. There we go. So here we have a handful of things. These are just the ugly cubes. This thing component references a runtime set, which is a scriptable object. And what this is going to do is when we click on any of these things, or sorry, when these things are enabled, they'll add themselves to the list, and when they're disabled, they'll remove themselves. This enabled things scriptable object is still, this is not a system, this is still just a collection of data. Meanwhile, we have this thing in the scene, the disabler. This has functionality to disable a random item in the list. So if you have, you can imagine this expanding to be something that's going to be your enemy target. This is responsible for assigning targets to enemies. So instead of just simply disabling a cube, it says some amount of time has elapsed. I'm going to pick an enemy in this list, a random enemy, and assign him to attack the player. So now this is a system that doesn't need to know about specifics in the scene. It's inspecting a scriptable object. That means that that reference can be maintained between scene loads, because this is a prefab referencing an asset. It's not referencing anything else in the scene. So there's also a text in this canvas here that says there are 5 things. That's just text that's inspecting that list and just printing out the number. So you can have a lot of things that kind of just operate on this as these observers. That's an observer pattern just looking at this set of data. But if I click disable random, it's going to do what we expect, which is it'll send an event using our game event system to the disabler, which will just disable one object from that list randomly. And again, you can see that these are all simple components. This doesn't make any assumptions as to where these objects come from. It just says, I'm looking at a list somewhere, and it's a dependency that's been injected into it by the inspector. OK. I also wanted to talk a little bit about enums and how they relate to data and scriptable objects. This is another thing that Richard Fine talked about in his talk, but I think it's important to bring up again. So I'm going to go through this kind of quickly, but yeah, he stole it from me first. Some of the limitations with enums, with enumerations, that they're all code-driven. And I think that the more code you can remove from your game, the less bugs you're going to have that are programmers' faults. So you can just assign all of your bugs to the designers, and everybody's going to be happy except for the designers. So if you have enums, you're going to have to change these things in code. So if we have elements, your fire, ice, and wind elements, I can bet you. So if we have element. So if you have enums, you're going to have to change these things in code. So if we have elements, your fire, ice, and wind elements, I can bet you somebody's going to ask for a new element at some time. So using an enum for that is something that you know you're going to have a feature add. They work out with things that are relatively fixed by some law. So cardinal directions, north, south, east, west, that could be an enum, unless your game, of course, wants to go into a more gradient space. We've used enums for comparison operators, less than equals, equals, not equals, greater than equals. So that's a place where there's not a lot of new comparison operators being invented every day. But that's the space where enums make sense, where you have a relatively fixed list. Using the enums and having them all be code-driven, they're difficult to reorder or to add or remove things. If these are serialized, the enums are going to be saved out based on their index. So if you delete one, you're going to break every single thing that uses that. I've seen games deal with this by renaming something to unused, and then that way they maintain the indices of everything that comes after it. And then you've got this massive list of enums that have 3 things that are valid because you don't know where they're actually being used. And then finally, they can't hold additional data, which is kind of obvious. You end up building sort of a lookup table in a lot of cases. And even if your initial definition here is we don't need it to hold additional data, somebody will. Somebody will want to put some data in there. And when you use your initial limitations or your initial expectations to define your implementation, I think that you'll realize that, yeah, that's a self-fulfilling prophecy. It can't do that, therefore it never will. So we can solve this, of course, with scriptable objects. Demo. So here we'll look at elements, and I'm going to look away, sample data. So here we have a handful of my favorite types of elements, rock, paper, and scissor. We all know how these work. I didn't write a fancy mover, so I'm going to drag things around in the inspector to demonstrate what happens here. These cubes each have an elemental component, which just references one of our elements. This is a scriptable object that extends that is of type of attack element. So here, all of this lists is what are the things that I beat? We know paper beats rock, rock beats scissors, scissors beat paper. So if I grab the scissors and drag them around, scissor on scissor, oh, that doesn't sound good. That does nothing. We'll edit that out. Scissor on paper, we know what's going to happen. Scissor on rock, that's exciting. It just died. So that's a very simple elemental system. But inevitably, you're going to have a designer come in drunk at night and say, I want dynamite. So here we go. Let's add dynamite. We all work with that guy. And dynamite beats everything. It beats rock. It beats paper. It beats scissors. It beats dynamite, which is just devastating. And I'm going to turn on these two special things because I knew I was going to do this. And we'll drag and drop this new dynamite right here into the element. So now these two at the bottom are going to be dynamite. So what I've done, and I could also have done this when the game was running, by the way. But what I've done here is I've just added a new feature, dynamite, going through, cleaning everything up, and just being destructive. So now we've added this new feature that, this small example wouldn't have been too much of a drain on your programming team to add one thing to the enum. But it's as your game starts to get larger, these things get to be much more expensive. And this also wouldn't break your reference index if this ends up getting deleted or reordered.
Yeah, that's pretty handy. So I could see this being really useful for localization. Localization, or maybe not, maybe localization isn't the right word, but translating your game from one language to another. So I have these guys, and then I can create a new script here. This can be like localized string. Translated strings. can do create language. Create Spanish. And then I can create a localized string, and this will be called welcome. And Unity Dictionary Inspector. Well, this would work if I could get the thing to show up in here. Whatever. Okay, I think this works if only we had a way to get the dictionary to show up into here. I'll have to write my own editor program to like add to this. Yeah, whatever.
have an update tick, which side of that, they don't respond to most of the Unity events, so they don't have an update tick. What I've done, and I could also have done this when the game was running, but, and this also wouldn't break your reference index if this ends up getting deleted or reordered. Okay, so we've talked a lot about modularizing data, and that's all well and good, but there's still things that you can do with, you still need more than just data points, these small chunks of data, in order to build your game architecture. So just like we can reference a variable that only has a float, we can also reference a scriptable object that contains the entire definition and all of the code that gets executed for a system. I'm sure everybody here knows that you can write functions inside of scriptable objects, but there's this sort of mental barrier where most people I talk to, they avoid it because they look at it as, this is a data bucket, it holds data. But you can write any method you want inside of that. They don't respond to most of the Unity events, so they don't have an update tick, which means that they do only what you tell them to do, which is kind of what you want code to do. So here we can go through an example of how we make an entire system packed into an asset. So if we make it a scriptable object, that system lives in the project, and it can be referenced by other prefabs or by other scriptable objects. You can just build that reference directly with the inspector. Again, this makes the inspector act like an injector in a dependency injection system. This makes it easy to see what system something's relying on, and it makes it easy to debug if there's, well, also you won't have race conditions with startup here because these scriptable objects are available on demand. There's also no code lookup, no inventory manager.instance, so this is very flexible, and you can even swap out what you're doing with your inventory manager. And you don't end up with any references in your scenes that say, oh yeah, here's my inventory manager game object if you did it that way, and this UI has a reference to that. That's saved in the scene data, and if you were to move any of those prefabs to a different scene, they wouldn't function. So let's take a look at how the audio mixer and the mixer group do this. The audio mixer has an option of selecting an output mixer group. So in your project view, you have one, and you drag and drop it in. So this is the pattern that Unity uses that's very much the type of thing that what we're looking for. I also want to give an example here for specifically an inventory system. On the game that we're working on now, we had an inventory where you have abilities. So it's an inventory of abilities, and there's a sort of telekinesis ability that your player has. And in our tutorial, we're going to teach you how to use that. But there's a problem that you can repeat the tutorials, and we don't know what the state of the player's inventory is at that point. So on past games, I've seen this be implemented by somebody saying, oh, we're just going to go in and modify the player's inventory. Instead, in our tutorial scene, we would just drag and drop a reference to a new material, to a new inventory. So we had a tutorial inventory that had only the item we were teaching, and then that was the one that we would reference in the tutorial scene, and we didn't have to make any code changes to support that. Right, so this inventory contains a master list. This is all of the items that are available. It has one scriptable object per item. This means that on source control, changing an item doesn't change this massive asset. And we have a lookup that happens on validate of the master list, or you can have it happen on other asset events that will just automatically populate it with every item in the scene, or in the project view. And as I mentioned, we can use different inventories in different scenes, like the tutorial example. So here we have an inventory asset that is the hub of our system. The player references that because the player says, my equipment, so display all of my equipment on me. We also have maybe the equip screen reference that. So now we need to have a prefab that's UI. This can have a direct reference to that asset. And that asset can then modify the inventory. And we can imagine an NPC wants to have access to the inventory. So this is where the NPC can say, I'm going to give you an item. And they don't need to know that the player is around. The player doesn't need to be in the scene. We don't need any special objects to exist. The player just says, I'm going to add this item to the inventory. And now here's where things get interesting. You can have your systems, so if you have an inventory system, reference other systems. So in this example, we can see our inventory can reference our save system. We could also have our inventory reference our localization system if it needs to do a lookup of text. So these are scriptable objects. The references that you tie between them are all going to be saved in your project view, so they'll be things that are guaranteed to always exist. I want to leave some room for some questions, so I'm going to skip over the inventory demo because I've just walked you through how it works. That's just about it. I want to remind everybody that the goals here have been to keep things modular, editable, and debuggable, which is going to let us make sure we can focus on building game architectures that are reusable across different projects, across different scenes, and hopefully across different studios. So I think that the game industry and the Unity community gets better if we're using similar practices. So I'd love to hear some questions at the microphones and some comments. And if you want to pick a fight over singletons, I'll be at the Unity party today. Thank you. Please use the microphone for your questions.
Yes. So I've got a question. One side effect of abstracting all of this is that you, for example, in the code, you can't look like references and such. Do you guys have had problems with it, like with debugging or with people that are new to the team to see like, okay, where's this thing being called from? It's a public method, so something out of like something is calling it, which is why we, for example, don't do that.
So I showed some very well. First of all, I can answer that. The samples that I showed were very simple examples that are very subject to that limitation. Tracing them gets more difficult. We have many more layers on top of that, and one of them that we've added is for our events specifically. Any invocation in debug mode is logged and displayed in the inspector. So it'll give you a full stack trace of where that was raised from. It also maintains a list, and the way that Unity handles serializing in a scene versus in the assets, so it uses the instance ID rather than a GUID file ID. You have to do a lot of fancy work to maintain the display. But we have our events, our debugger for our events also let you see every single thing that's registered. So in the inspector, or even in the scene view.
Okay, I'm not going to listen to all that. So it's getting pretty late, and I'm going to stop here soon, but I want to make one bit of work towards refactoring what I've got so far, and what I want to do is I want to turn this jump state variable into a scriptable object. No. I don't know. I'm gonna have to think about it and come back to it. And I have a bunch of things right now in that I haven't saved to plastic, so I'm just gonna save. Yep, bye. Thanks for joining. All right. I think we're all done for tonight. So thanks for joining my stream, and as always, have a nice night.